Hi, it's Jeff with Cribl. In this video, we're joining Randy Corelli as he walks through what Grok Patterns are, as well as how to create, use, and manage them in Stream. He covers an example of breaking a Grok pattern down to its regular expression and demonstrates the parsing results for a sample event. Finally, hear about a real-world use case to review and import a Grok pattern from another source, in this case Nginx, into Cribl. Let's join Randy as he gives an office hour style walkthrough and demonstration.
Good day, everyone. Today we're going to take a look at Grok Patterns, kind of what they are, and how we can create and manage them and use them within Cribl Stream, including here with the Grok function in the pipeline that would be used to parse events. And finally, we're looking at a real-world example of taking an existing Grok pattern, or in this case, kind of 5 of them that were kind of ORed together, and how would we migrate that from that third-party system into Cribl Stream. So that was where Nginx was performing the syslog processing before, and now we want to move that feed into Cribl, but we still want the same parsing results. So we're going to kind of build from the basics up to that more complicated use case here at the end. So ultimately, what is a Grok pattern? Really, it's just a nice way of defining named patterns for regular expressions or regexes. So that way, other people don't need to know the regex syntax to actually make a parser. They just need to know those different pattern names and how they go together. And that makes just things much more simple to read and user-friendly, but also allows a bit of reuse, because if you change the regex for a given pattern, any other patterns which reference that one will also then get updated with that fix. And you don't have to go changing things in multiple spots. So that management is also quite nice, but really it is also here really well for that user friendliness. If we look here at this docs page for the Grok function, you can see how we can use it. And you can see that to parse this event, here we extracted the timestamp, the logging level, and the message kind of portion as 3 separate A, B, and C. And the regex for this would be pretty long, but here it just took these 3 patterns, saying I'd like this timestamp ISO 8601, and if it matches that pattern, I'd like to assign the value to event_time. Same thing with the log level pattern to this log level field, and we're going to use this greedy data pattern for the log message. So rather than needing to actually know anything regex, if you know how these patterns go together, then somebody can build these Grok function or this Grok pattern in function to parse an event successfully. So let's go take a look at the knowledge libraries, but first let's take a quick look at the docs page. I always like to highlight those. So here in the knowledge libraries, the Grok pattern library section just shows a little more detail about those. And really a pattern library is just a file that groups common Grok patterns for a use case. So you start with say the core patterns that we might see here. And these would be kind of your building blocks, like what's a username or what's a word or even a space, any keyword that you may want, a non-negative integer or a positive integer. So usually things that are common to almost any log would go in something like your core patterns or a similar kind of library. But ones that get more specific, so say like for firewalls, these only apply to like a Cisco device or a Cisco ASA firewall. So there's no need to have those if we're parsing some other data type here, right? Or another system type. So things that go together logically, we kind of put them in their own pattern file just for management. When we use them, we don't actually need to reference the file name. Our pattern names that we reference in the Grok function will apply kind of or get looked at across all of the pattern files. So let's take a look at one of them here. So say for this timestamp, just to parse out this function here, that's this pattern. And let's kind of go through how we can break that down into its subcomponents and see just how complicated the regex is for this pattern. Especially in this case where these patterns try to take into account some anomalies, and so maybe a bit more in depth than you might just put together a quick and dirty regex. So for this timestamp, ISO 8601, and I like to just search these files. So if we click inside and just do a web browser search, it's a lot easier than trying to scroll and find them. And we'll tell you if it's in this file or you have to go looking at another one. But here we found our pattern name, and then next to it, that's telling us what the replacement for that pattern actually is. And in this case, it's a series of other replacements that now also need to get translated. So the underscore year, and if we just kind of keep track, we see that's up here. And this now is just a basic regular expression. So we would fill this in. The month number, right, becomes next, or that month num. If we scroll up a bit, we find month num as the name. And so that's going to be this pattern. You kind of see what the system would be doing in the back end as we're going through this. Month day was next. So that would be this pattern is what this is referencing. Then it's saying this is, regular regex expression of a character class that can either be the capital letter T or a space. And then we're going to do another replacement with the hour. So that's this one down here. And then the minute. Then over here, kind of the second. And we can identify those replacements again by that % with the curly braces. And everything else is kind of other regex syntax. So we're just going to leave that as is without changing them. And then here, just this ISO time zone. So let's do a quick search for that one. And that comes up here. Now, of course, the time zone also references the hour and the minute. So 2 more, and then we're done. Here's the pattern we started with, and that led to this pattern, which once you decode it all, leads to this regex. So I don't know about you, but I would much rather just be able to reference this name, this timestamp ISO 8601, and not have to actually type or retype this expression anywhere. And if we want to see that in action on an actual value, I did create a simple kind of eval statement with that regular expression, as well as the Grok with the Grok pattern. So let's just go take our event here and go see that it properly matches both ways and just shows the ease. So first, let's do the hard way with our eval statement. And we can see here that big long regex. And here, if you want to try that one, it's our field that we'd like to check against, dot match. Then within the brackets, our parentheses, we put the slashes, and between those slashes, we put our pattern. And here, if we replace this underscore row, we can already see that the timestamp format is matching for this format and extracting that value like we would expect. But from our test event as well, we see that with this format, it's equally extracting that. So that is working and gives us the value we would expect. But of course, right, that was pretty complicated as a expression. The simpler way to get that exact same result is this little pattern. And how nice and tidy is this? And when we give it that value, I think I need to make a change up here to get it to kick in. We actually see, right, that it instantly just extracted that same value for us. So that is super nice and kind of why we use these Grok patterns. And if you haven't used them before, but you use regexes a lot, I definitely recommend them. And that's kind of the basics. So if you're not interested in the more advanced use cases, that's kind of the overview. But now let's take a look at a broader customer scenario, or I guess before that, let's take a look just at a pattern in action to actually process some events and see the input output a little more than just that one little simple pattern. So here, since I've only done it for the beginning portion, we're just going to copy up to this timestamp. We're really just matching up to this metric beat chunk here in the middle. But if we take our pattern and open this one up and replace our value, there we go. We can see here that we was looking for a less than sign, and then this positive integer Grok pattern followed by the lesser than sign, and we're going to assign that value to the syslog_pri. So that's this value here, the 30, and we see that was extracted as we'd expect. Next, same thing, syslog timestamp is a pattern, and we're calling it syslog timestamp, and that did in fact pull out that syslog format for us. Next is a space pattern, and we could equally just put a space character here, but you can also reference that pattern to show that there is that character, which can be helpful sometimes. Then the host name pattern, and we're going to assign it to host name, and then just followed by a space, and this word pattern going to process name. And you can see that when you get through them, we end up with all 4 of those named fields with their expected value from our sample event. So that's a little bit more of an example here of just how that pattern works. And if we actually just run that here and see the output, that's where we're going to see those extracted fields on all our events, the host name, the process name, that syslog priority, syslog timestamp, and you'll see that across all these events. So that's kind of seeing it in action and how you might either build or test as you're going through those. So the next kind of example I wanted to walk through was just how do you take something like this, which was a bunch of patterns, and actually put this into Cribl. So the first thing we would do is obviously, right, let's just try what we had in our other system. And for this one, we're just going to go just to my normal pipeline, because I did create one. Oh. In fact, I guess we were already there. Let's just delete these, or at least that one. So in our Grok pattern here, right, if we put that big block in, if it accepts the pattern, there's some validation that when we click save, it will save successfully. If there's any errors or issues with this, it's going to tell us. So the first error, or the first problem it has, is 2 named subpatterns have the same name. So what that means is that amongst our patterns, these field names that we're assigning, that's reused more than once. And if we actually look here in our text editor and search for this one, we will see that this one here is defined 3 times. Syslog timestamp is used a few times. So what I had found with this one was these ors, so a pipe in this kind of syntax was an or. And so they actually had multiple Grok patterns here in this Nginx format looped into one big block. So the first thing that I would do in tackling this kind of problem is to break out any of these patterns, or ors, if you will. It's kind of message pattern 1 or message pattern 2 or message pattern 3. And you can kind of see they get a little bit different or less specific by the time you get to the bottom. It's a little more like a fallback. So we want to keep that same order so that they would match in the same order as before, because something that matches this first one may also match the second. But in this type of syntax, the first match, and that will bail. It'll exit, right? So if it matches pattern 1, it's not going to try to go to pattern 2. But we're going to take a look at each of these patterns individually and just make sure that one by one here, so we'll end up with 5 Grok patterns when we're done, and we just want to make sure that there's no issues with each one. So starting here, and we can click save, and we see now that this pipeline saved successfully. So this pattern that we have is syntactically okay. So for the next one, we just kind of go through that same process and tackle any issues as they come up. So add function, go to our Grok. Here in our pattern, we can just paste it and we can try to do a save. So here on this one, it tells us that a subpattern name is expected, and it kind of tells us the position, right? The number of characters in where it's at. And if we scroll through here, we pretty well end up at this @ timestamp section. And it turns out it doesn't like the @ sign in this syntax here. So if we remove the @ sign and just call our field name timestamp, then it's going to save that successfully. If I was approaching this as a real world situation for myself or a customer, then I would also want to be looking maybe for consistency. Right here, we were using the syslog timestamp pattern and giving it a syslog_timestamp field name. But in this pattern, we're using that same pattern name, syslog timestamp, but we're assigning it to a different key name. Now, there may be a reason for that. We want to treat these events and these values differently. That's possible. Or somebody just maybe made a mistake and we wanted them to be consistent and we just put in the wrong name. So while you're doing that, just kind of review this and see if it makes sense. If it does, to keep it as timestamp, go for it. There was no issues. But otherwise, making these consistent, especially when we see the formats kind of the same of the syslog priority, then the syslog timestamp. Same thing here, syslog priority, the syslog timestamp. It does help to have common names if you're doing other eval statements or other pipeline functions on your events once you parse them. And maybe saves you some other normalization as well. So now we look here at the third one. Since our second one, we'll resave to make sure it's still happy here. Yep. And now again, we just add another one. We can go to Grok, put in our pattern, and try to hit save. And in this case, the pipeline saved successfully. But again, I did notice here that this one's called priority, where previously here that initial parsed value was being called syslog priority. So again, there may be a reason that we want the different names, but for consistency here, we're going to make that update as part of improving our pattern and not just migrating what we had for the same reasons I discussed on the syslog timestamp. So again, now we'll save that, and the pipeline here is accepted, so we know the first three are good to go. So now let's take a look at this fourth one. And we hit save, and the pipeline was accepted as is. Our syslog timestamp and syslog_PRI or syslog priority. The field names look good, so no changes are needed on this one. And then our last one here is another one where we're going to go digging into the library a little bit, because when we first save it, it's going to give us a naming conflict. Right? That two subpatterns have the same name. And it's not immediately obvious in this case. Right? When we first started and we just had our big block, all right, it was pretty easy to see that, oh, I have this field name in 2 or 3 spots. But after it's been separated, when I look at just that pattern, nothing in here tells me where priority is used. Or is it this name or just what's going on here? And because I wanted to make this consistent, if I change the name away from priority, this is the only name referenced in the pattern, so the only one I can really change without digging into my library some more. If I change the name, then I find that it is accepted. And so we know that was the conflict, right? That's what the validation didn't like. So, we could just stick with that one. But if we wanted to understand a little more of where in the syslog line we came up with that priority, or just to verify that in that chain did indeed have a field name called priority, that's where we can do that same deconstruction we did over here of starting and just going through each of the patterns that they reference until we see where we get that one. So back to our knowledge object, and here the syslog line, I believe that's in the Linux syslog. We see that here, syslog line, and that's replaced by these 2 patterns. And then syslog base 2, which we see up here, right, is now that pattern. And greedy data, just to kind of go through that, would be under core patterns. And we see greedy data here, right, is just the dot star. So this first one breaks down to the second one, and that one in turn breaks down to this here. So greedy data is already just a regular expression, so it can now kind of be ignored. But let's look at that syslog timestamp. And that'll be back over here. Oh, no, I guess those are in the core pattern. Just have to scroll down. All right, syslog timestamp. And that's pretty basic. Just year, month, day. The other one here, this timestamp ISO 8601, we've kind of already seen. And again, right, it breaks down to pretty self-explanatory blocks, year, month, day, hour. So nothing here that would indicate priority. So we continue onward to our syslog facility. We see that down here. And syslog facility, we do see one field called facility and one here looking for a non-negative integer that is named priority. So in going through the syslog line, there is indeed a subpattern which had that field name that caused the conflict as we saw before. Then just to kind of finish things off, we'll put the syslog host in here and the syslog program. So I'm not going to go through the rest of breaking this down, but this is how we can now confirm that basically it was this syslog facility pattern that introduced that priority name. And that's why over in our pipeline, we weren't able to call this other positive integer priority. That was already being assigned over here. So we needed a different name over here. So that's nearly there for the patterns. That's all 5 of them. But the one change we need to make is to make all of these final. Because the problem, if it matches more than one, if we don't make them final, then it can match this first one and then match the second one and maybe override the field names and the values in an unexpected way. So to truly match the order that we had here of the first one or the second one, if we make all of these breaking or final, rather than if it matches the first one, it won't try to match against the second one. But if it doesn't match the first, then it will try the second, and so on down through the third, the fourth, and the fifth. So if it matches the fourth pattern, we know it didn't match the first 3. And now we actually have that same OR logic that we had over here. Rather than just being one big block like they had over in Nginx, we now have 5 regex patterns here that we can now use against those same events. So if we bring in that same event stream as we have, then we would expect kind of similar or the same output as we got from Nginx. There may be some tweaks in here. I haven't actually tested that with the those live events, but that is the general process. So I hope that helps to demystify Grok patterns a little bit. And if you don't like regular expression syntax, then being able to just define things once and now have a nice name that you can remember forever is where you can create your Grok pattern libraries and now simplify your pipeline parsers. Instead of needing those complicated regex expressions, you can now use these nice named Grok functions, Grok patterns here with the Grok function.
Thanks, Randy. If you want to learn more, you might want to look at our documentation at docs.cribl.io, or take a sandbox for a spin at sandbox.cribl.io. And last, please be a part of the community at community.cribl.io. As always, thank you for watching.